Hello guys, welcome to Maths by Budania sir. In this video, we will solve a very important case study question from the chapter Inverse Trigonometric Functions taken from the 2024 board exam. Here we will explain the concept and solution step by step. Don't forget to subscribe and press the bell icon to get updates on all types of questions, be it MCQs, case study, assessment region, and descriptive 2, 3, and 5 marks. Pause the video, try the question yourself, and then watch the solution. Okay, let's get started. Here, firstly, we will see the concepts to be used here. First is inverse of a function is only defined when it is both 1 1 and onto. Means function should be bijective. Bijective function is the function which is both 1 1 and onto. 1 1 means for different input function gives different output. Onto means range of the function is equals to codomain of the function. Let's understand what we want to say. Let's say I'm saying that this is a set A and this is set B and function is defined from A to B. Let's say elements of the set A are x, y, z and elements of set B are 1, 2, 3. And image of x is 1, y is 2 and z is 3. So here we can easily see that for different input, we are getting different output. If input is y, then output is 2. If input is z, then output is 3. Here for different input, we are getting different output. So this function is 1, 1 function. Next, what we are saying that for a function to be onto, codomain of the function should be equals to range. So here codomain of the function is that is set B. And range of the function is also set B, because if we make a set of all the images, it will be equals to set B only. So here codomain of the function is equals to range of the function. So here we say that this function is onto function. As this function is both 1 1 and onto, so we can say that this function is bijective function. So what we want to say is inverse of a function is only defined when function is 1 1 and onto. Next is domain and range of original function becomes range and domain of inverse functions respectively. Here in this example, let's say we define a function from B to A. Okay, so this function will be inverse of this original function f. So this function will be f inverse. Now codomain of original function will become a domain of inverse function and domain of original function will become a range. So we can write this function as 1, 2, 3 and this is x, y, z. So f inverse function is defined from set B to A. Image of 1 is x, 2 is y and 3 is z. So here we can clearly see that the original function's codomain becomes domain of the inverse function and domain of original function becomes codomain or range of the function. Clear? Next is, this is very important, graph of a function and its inverse are mirror image of each other about the line y is equals to x. This concept is very important as it will help you to draw inverse trigonometric functions graph easily if you know the graph of trigonometric functions. This concept we will be going to use in case study question number 3rd part. Next concept is if we add or subtract any number to an inequality, then sign of inequality remain unchanged. This concept is from class 11th only. Here I have written this concept for the revision purpose. Next concept is if we multiply or divide any inequality by positive number, then inequality sign remains unchanged. Next is if we multiply or divide any inequality by negative number, then inequality sign will change. So if we divide or multiply any inequality by negative number, then the inequality sign changes. If it is greater than equals to, then it will become less than equals to. If it is greater than, then it will become less than. Okay, sign will reverse. Next concept is principal value branch of sine inverse x is the branch with the range minus pi by 2 to pi by 2. Now let's proceed to the case study question. Case study says if a function f is such that it is defined from x to y, defined as fx equals to y is 1 1 and onto, then we can define a unique function g such that it is defined from y to x. Okay, such that gy is equals to x, where x belongs to capital set X and y is equals to fx, y belongs to capital set Y. function z is called the inverse of f. The domain of sine function is R and function sine is defined from all real numbers to real number is neither 1 1 nor onto. The following graph shows the sine function. Here what we want to say is that if the sine function is defined from all real numbers to real numbers, means domain is real number and codomain is also real number. So it is saying that it is neither 1 1 nor onto. From graph we can easily see that this function is not 1 1. For 1 1 function, for different input the output should be different. But here we can easily see that for input pi by 2 and input 5 pi by 2, the output is same, that is 1 only. So it is not 1 1, it is many 1. Okay, next it is saying it is nor onto. Here codomain is defined as set of all real numbers, but here we can see that the range is from -1 to 1. Here the range is subset of codomain, so this function is not onto. From here we can conclude that we cannot define inverse function of sine. Okay, to define this inverse function of sine, firstly we have to make this sine function 1 1 onto or bijective function. Clear? Let sine function be defined from set A to -1 to 1 such that inverse of sine function exists. That is, sine inverse x is defined from -1 to 1 to A. For the sine function to be invertible or its inverse to be defined, then we have to make it 1 1 and onto. So here we are saying that the domain of the function is -1 to 1. Okay, so if we take this branch of this function from a minus pi by 2 to pi by 2, here I am saying that if fx is defined from minus pi by 2 to pi by 2 to -1 to 1 and fx is equals to sine x, so we can say that now the function sine x is 1 1 onto, because for different input you will be getting different output. For all these inputs we are getting different output, so it is 1 1 and range of the function, that is -1 to 1, is equals to codomain of the function. Clear? So it is 1 1 onto. So here we can define the inverse of these functions. Here we can say that sine inverse of x is such that it is defined from -1 1 to minus pi by 2 to pi by 2. Here domain of original function will become codomain of the inverse function and codomain of the original function will become domain of inverse function. Clear? Now in concept part we have seen that principal value branch of sine inverse x is the branch with range minus pi by 2 to pi by 2. So here what we are saying that if we are considering this branch, the inverse function which we are getting, this branch is called principal value branch and its range will be minus pi by 2 to pi by 2. And one more concept, here we can also see that we can take branch pi by 2 to 3 pi by 2. Now corresponding to this branch, sin x function is become 1 1 onto, and here we can also define its inverse. Clear? But the branch here we are taking from minus pi by 2 to pi by 2 corresponding to this sine function, the sine inverse function we get, we call this branch as principal value branch. Now let's proceed to the questions. Question 1 is saying if A is interval other than principal value branch, give an example of one such interval. We have already discussed that we can also define inverse function corresponding to this branch. A can belong to pi by 2 to 3 pi by 2 because principal value branch of sine inverse x is with the range minus pi by 2 to pi by 2. Other than this, we can also say that we can define inverse in this interval also. A belongs to 3 pi by 2 to 5 pi by 2. So in this manner, we can write infinite intervals. Clear? So here it is asking one example. So we have given two examples, that is more than sufficient. This is the answer. Next it is saying if sine inverse x is defined from -1 to 1 to its principal value branch, find the value of sine inverse -1 by 2 minus sine inverse 1. Okay, so here it is saying that range of the function is equals to minus pi by 2 to pi by 2. because in question it is given that sine inverse x is defined to principal value branch. Okay, now we have to find the value of sine inverse minus 1 by 2 minus sine inverse 1. So now if you are not able to directly answer this value, then you can consider this as, let's say, sine inverse minus 1 by 2 is equals to, let's say, theta. So sine theta should be equals to minus 1 by 2. So from here we can easily see that between minus pi by 2 to pi by 2, the value of sine theta is equals to minus 1 by 2. At what theta the value is minus 1 by 2? That is minus pi by 6. So here we can write this directly. The value of sine inverse minus 1 by 2 will be minus pi by 6 minus. Similarly, we can see that sine theta is equals to 1 is for pi by 2, sine pi by 2. So here we will get pi by 2. So we can write this is equals to, we can take LCM, minus pi minus 3 pi is equals to minus 4 pi by 6, and here we can simplify this. 2 2 ja 4, 2 3 ja 6. Answer will be minus 2 pi by 2. This is the answer. Clear? Okay, now in third part it is saying draw the graph of sine inverse x from minus 1 to 1 to its principal value branch. So here what is it saying is that you have to draw the graph of sine inverse x corresponding to its principal value branch. Okay, so to draw the graph we have to consider the line y equals to x. That will be a straight line making angle pi by 4 or 45 with x-axis. So this is that line. So here what we have to do is just draw the mirror image of this branch, and in this side we will get like this. Okay, so from here we can easily draw graph will be like this. And now as domain and codomain changes, so on y-axis this point will be, we know that it will be pi by 2, and this point will be minus pi by 2, and this point will be minus 1, and this point will be 1. Now on y-axis we are writing the values of x-axis of sine x, because in inverse function we have already studied that domain and codomain reverses. Clear? Third or part is asking find the domain and range of fx equals to 2 sine inverse 1 minus x. So here the function that is given to us is fx equals to 2 sine inverse 1 minus x. Okay, so first domain 1 minus x. One more thing, if in the question it is not given, it is not specified of which branch it is talking about, you have to take it as principal value branch as default. Clear? So here we are talking about principal value branch. So we know that 1 minus x corresponding to principal value branch, input of sine inverse x can vary from minus 1, that can be greater than equals to minus 1 but less than equals to 1. Now subtracting 1 from the whole inequality, we will get minus 1 minus 1. Inequality sign will remain unchanged. 1 minus x minus 1 and 1 minus 1. So here we will get minus 2, 1 1 will get cancelled out, minus x 0. So now multiplying minus 1 to the whole inequality, now sign will change. So this will become 2, that is greater than equals to x greater than equals to 0. So from here we can say that domain of the function will be equals to 0 to close interval. Now for a range, we know that the value of sine inverse 1 minus x, we are talking about principal value branch. So value of this whole function lies in the interval minus pi by 2 to pi by 2. But here what we have to find is find the value of or range of the function 2 times of this function. So we multiply 2 whole inequality. Inequality sign will not change. It will become pi less than equals to 2 sine inverse 1 minus x is less than equals pi. So from here we can say that range of the function is equals to minus pi to pi, and this is the answer. Okay, here we end the video. If you like the video, smash the like button and share this video with your friends so that they can also get benefited. See you in the next video. Bye bye.